Hey guys, welcome to a new video in this neural networks and deep learning tutorial. In this video we're going to talk about optimizers and we're going to talk about the loss functions in neural networks and then how we can use the learning rate and what the learning rate is in optimizers and when we're using the learning rate in optimizers and how that is done and how it affects the training process of the neural network. So we'll first have a short recap here, what we learned from the last video. So in the last video we talked about the artificial neural network, where we talked about the structure, where we have different kind of layers in our neural network, where we have an input layer and then we have an arbitrary number of hidden layers, where each of these nodes here is neurons in the neural network, and then we also have output layer output layer here at the end, which is like the results for passing through data in our network, which is the feed forward method. And we also talked about some of the elements in our neural network where we have these different kind of layers here, and we have to wait for each of these connections here between neurons, and then we also had a value for each neuron. And then we also talked about like some of the activation functions and how activation functions is used and what it does in neural networks. So we talked about these layers here in activation functions, and we saw some different types of layers, and with the dense layers and some of the convolutional layers. And we also saw some different kind of activation function with the ReLU and sigmoid and stuff like that. And then at the end of the video we saw how we can create a model in Python with Keras, and we actually like did that, where we created our own sequential model and added 3 layers with different types or like different number of neurons. And then we created a model in 2 different ways and had a summary over the neural network, and saw how many different kind of parameters that we can actually like tune and how many parameters there were in our neural network. So in this video here we're going to focus on like how we can optimize our neural network during training and some of the like elements that is happening during training. And then in the next couple of videos we're going to do actual training of the neural network that we created in Python with Keras, and then we can afterward train a model and we know like how a model trains, then we can do actual predictions on new data that our neural network hasn't seen before. So in this video here we're going to talk about optimization, and we're going to talk about loss and loss functions and the learning rate that we have when we're doing optimization. So first of all, like in loss and loss functions, we're going to talk about what it is and what it's used for, and we're going to see some examples of different types of loss functions in neural networks and like how they affect each other and how they work. And then we're going to talk about optimization of neural networks when they're training, and like the optimization of the learning or like training process. So we're going to talk about what it is and what it's used for, and we're going to see some different kind of optimizers in neural networks. And I'll talk about some of the pros and pros for some of the optimizers in neural networks. And then at the end, when we're doing optimization, we also have something called learning rate, and we're going to talk about what the learning rate is and how it affects the neural network during training, and also like how we can choose the right learning rate and know like when should we choose at this number or like some learning rate for some different kind of situations or applications, because that is really important when we're doing optimization, that we choose a learning rate that is really good or like it fits for our application and neural network. So we'll first talk about like loss and loss functions in neural networks. So the objective of like doing training of our neural networks is to minimize the loss function by iteratively updating the weight in our network, because the loss in our neural network is calculated by using the true labels from the input data and then the predicted output from the neural network. So when we're training our neural network, we're passing new data to our neural network, and then from that neural network we will make a prediction. And then the output from that prediction, we're going to compare that to the true labels or like what it should have been predicted, and then we can calculate the error of the neural network's predictions. So the error here is equal to the model's predictions minus the true label. So let's say like we, for example, wanted to predict a dog in an image, and the model's prediction here was 0.5% or like 0.5 that it's certain, the probability of that it is a dog, it's 0.5. And then the true label in this case here was 1, so we will have an error here of the model's predictions, which is 0.5, and then the true label here would be 1, so we will have an error here in our neural network because we haven't predicted a true label with our neural network yet. And then this error here, we're going to use this to train our neural network and backpropagate in our neural network. So this is the loss or like the loss function that we're going to trying to minimize while we're updating our neural networks during training. So we have some different kind of loss functions that we can use, and one of the most used ones is the mean square error, where we're just taking like where we're just squaring the error. So this is the same equation as up here, and this is only for one sample where we don't take the mean. but this is just a squared error here, so we're just squaring the error that we're calculating with the model prediction and the true labels. And then if we have multiple samples, which we will have in our neural network when we're training, then we'll take the mean of all those squared errors, and then that will be the error that we're going to try to minimize with our loss function and our optimization. So a loss function here, we have different kind of loss functions where we have some regression loss functions, which is the mean square error, as I just talked about. An example over here to the right, we have a demonstration of what the mean square error does. So let's say that we have some prediction here from a neural network, which is this data point here, and then we have this linear graph here, or like this linear here, and then we're going to calculate the error here, like the error from the predicted value to the true label, which is the blue line here. So this will be the error here, like the difference between this value here, or like this data point here, and true value down here. So we'll take the mean squared error, and then when we take the mean squared error for all of these data points here, or all the predictions in a neural network, then we can calculate like this linear regression here, and then we can use that in our optimization, or as a loss function where we're trying to minimize like the loss in our loss function. So we will have these, like the objectives of minimizing the loss function here is to get like this distance here should be like the minimum as possible. So optimally, all these points here, all these data points here should lay on this linear regression line here, and then we will have found the most optimal model to actually do predictions on the data that we wanted to. We can also have some other probabilistic loss functions where we have categorical cross entropy, or like sparse categorical cross entropy, binary cross entropy, and a lot more. We're going to talk about these different kind of loss functions more. I'm going to show you the Keras API documentation where we can see when we should use some of these loss functions and in what different kind of applications they're good for. So probably the two most used ones is the categorical cross entropy and the mean squared error, and it just depends on your application. So we're going to talk about that as well. So now we're going to talk about optimizers in neural networks. So when we are having when we're trying to optimize the learning or like the training of our neural network, then we are talking about like the gradient descent algorithm. And each of these optimizers here that we're going to talk about is some specific implementation of the gradient descent algorithm, and some of them have some different kind of properties to make it better and make it more optimal optimizer for different kind of applications. But like the main idea behind gradient descent is that the algorithm, it depends on the first order derivative of a loss function. So we choose a loss function, and then the algorithm, or like when we do our optimization, we take the first order derivative of that loss function, and then we calculate the way the weight should be altered so the loss function can reach a global like a minima, and the global minima is the goal, and it depends on the learning rate. So let's say down here that we can like try to visualize the gradient descent here, and then we have different kind of specific implementation of the gradient descent. But the gradient descent here is that we have some point here, or a weight that we initial weight here, and then we're taking the gradient to this weight here, where the gradient is when we're taking the partial derivative of the loss respect to the weight that we're now dealing with. So we take the gradient for that weight, and then we're having our learning rate where learning rate depends on like how fast we want to learn and how big steps we want to take in our learning process. So we're going to talk about this here as well, with the learning rate and how it affects the training process of neural network. But then we're taking the gradient here, and then we're training a model to try to hit a minima down here. And this is the idea behind gradient descent, where we're trying to like find the way the weight should be altered so the loss function can reach a minima, which is optimal down here, which is the global minima of like our function here. So some of the optimizers here that we're going to use in neural networks is the stochastic gradient descent, which is one of the most used ones, together with the adaptive moment estimation, which is the add-on optimizer. But we also have some other ones here, which is the root mean square probability and adaptive gradient algorithm. So these are like one of the most used optimizers in neural networks, and we're going into the API documentation to see like in which different kind of situations are we going to use this. And I'm also going to create a new video where we're going to like try to compare all of these different kind of optimizers and also the loss functions, and we're going to do a comparison with some of the pros and also some of the cons of these different kind of functions and optimizers. so you know like which optimizer or loss function you should choose for some different kind of applications and in some different kind of situations. So the learning rate in neural networks is also very important when we're doing optimization and also like just in the training process of our neural network. So the learning rate is the size of the steps that we're taking to reach our minimized loss. So we already talked about this when we're doing our gradient descent in the training process. So the learning rate is determined like how fast we want our model to learn. So we can see an example down here with some different like types of or like different values of the learning rate. So we can see like if we have a too low learning rate, we will not go or we will not reach the minimized loss. So the minimized loss is down here at the bottom, which is also the global minima. So this is the objective to reach when we're doing our training of a neural network. So we can see if we have a too low learning rate, we will never reach our objective. And we can see if we have a good learning rate, like we're taking nice size of steps, and we're also like we go past the global like the local minima, and we also go down towards the global minima of our learning process. If we're taking if our learning rate is too high and we're taking too big steps, then we can see that we can't get into like the global minima, and we will only reach a local minima, which is not the objective of neural networks, and we won't have a neural network that is pretty good at doing predictions. And if the learning rate is just too high, like we won't even reach a local minima, and we can see that the learning rate is just too high and we won't get any good results in our neural network and when we're doing predictions with our neural network. So we can see a comparison of the different kind of learning rates down here, where we see like a good learning rate is just having this nice steady decay when we're going over the epochs. So the epochs is the number of times that we're training or like passing the data through our neural network. So we can see that if we have a too high learning rate here, we will just converge towards the local minima. And if our learning rate is too low here, we can see that it takes too long time to reach the global minima, and we will just need to train our neural network for a lot of time, which is not really necessary if we can just choose another learning rate that takes a bit higher step size, and then we can reach a global minima both faster and also reliable. So we want to get stuck in a local minima and we will reach the global minima. So we can see that this green here is the most optimal one because we converge towards the global minima and we don't get stuck in a local minima, and also it doesn't take too long to get to the global minima. So this is the objective of the learning rate and also like how the learning rate affects the neural network when it's training. So we can use this learning rate here in our optimizers, and we're going to see in code like how we can specify this learning rate here as a parameter for our optimizer. And then in Keras, we will just use the optimizer and we will specify the learning rate. And then all of this here will be done under the hood in the code. So first of all, here we jumped into the Keras API documentation. I just wanted to show you like where you can find documentation for some of the like optimizers and loss functions, and also some of all of the functions that we're going to use in code as well in some of the code examples. So if you go into the Keras website here and we go to the Keras API reference, then we can see the different types of things that we can use. So we can have this models API here where we can go into this and see the different types of functions that we can use on our models. And then also the layers and the data pre-processing if we want to do some pre-processing of our data before we pass it to our neural network. And then we can also see the optimizers and the loss functions and some different kind of stuff that we can use in our neural network. So in this video here, we talked about the loss functions and optimizers. So let's go down to the losses here and see some of the things that is already like that is implemented in the Keras API. So we can see that we have these probabilistic loss functions and also the regression loss functions, and we talked about some of these here in the video. So we have these categorical cross entropy classes and the mean squared error classes. So if we just go into one of these here, like for example the categorical cross entropy class, then we can see some of the like we can get an idea of what it is, and we can also it tells us like what it does and also like how it affects our program or like a neural network while it's training. And sometimes they also say like in which different kind of situations is it good to use this type of a loss function, or in the case we want to find a good optimizer for our application. So we can see here that it computes the cross entropy loss between the labels and the predictions, and it used this cross entropy loss function when there are two or more labeled classes. We expect labels to be provided in a one-hot representation. If you want to provide labels as integers, please use sparse categorical cross entropy loss. There should be number classes floating point values per feature. So we can see like when we should use some different kind of loss functions for specific situations, and even tell us that. And they also show us an example of like how we can have some labels and some predictions, and how we can use this this loss function in the code. So we can see that there's some different kind of examples down here if you want to go into the documentation here and see how you can actually like use this in your code. So the other one here that I'm going to show you is the optimizers, where we can go in here and see what different kind of functions take the optimizers as a parameter, and what can be passed to a parameter to the specific optimizer that we're going to use. And then we can see the different kind of optimizers, how to use it in code when we're compiling our model. And we can also see like if we want to do our own custom training loop, we can also use the optimizers in that way, and we can see we have a learning rate decay or something like that. And also the available optimizers that is already implemented in Keras that we can just use and import them from the Keras library or module. And we can see that we have this stochastic gradient descent and the RMS prop atom and attacrat that we already talked about in the slides. And I'm going to do a comparison of all these different kind of optimizers and loss functions that I've just showed you, so you know like what loss function and also like what optimizer you should use for a specific application. So we're not into the code here, and the first blocks of code here, we already implemented this in one of the previous videos, where we created this sequential model here, where we created like the architecture of the neural network that we're going to operate with in this tutorial. So we created this sequential model here as we can do with the Keras API. So we created these three layers here, where first of all we have an input layer with 4 neurons and an activation function of value, and a hidden layer here with 3 neurons and activation function as value as well. And then our output layer, it has 2 neurons, and the activation function is softmax, because we're going to do some classification with our neural network here that we've created. And then we're going to do this summary here of a model, so we can see that we have actually like created the model that we wanted, and we can see the number of parameters that is both like trainable and like the total number of parameters that we have in our neural network. So this was just another way that we could create a sequential model. So let's now go down here. What we're going to do in this video here is we're going to compile a model so it's ready for training. So in one of the next and upcoming videos, we're going to actually like train the model that we have compiled in this video here, and we're going to have some random data that we're going to generate and then train our model on that, and then we can do some predictions on new data that our model hasn't seen before. So first of all here, that we just saw from the Keras API, we have some different kind of optimizers and loss functions. So from the optimizers here, we're going to import from Keras the atom optimizer, and the loss function that we're going to use is a categorical cross entropy. So to compile a model here, before we can actually like do training on a model, we have to compile it. And when we're compiling a model, we need to specify the optimizer that we're going to use during training, and also the loss function that we're going to use during the training. And then we have some metrics that we can use for seeing like the results during our training, so we can actually like follow along like how our model is performing while it's training, and how it's getting better and better over the episodes or epochs. So first of all here, we're going to specify this atom optimizer, and then the atom optimizers take this parameter here, which is the learning rate, and we could like play around with this learning rate here to find the most optimal one, as I just talked about in the slides as well. Because if we don't have the real a good learning rate for our optimizer, then we will just hit a local minima, or not even hit a local minima. And the objective when we're doing this here is to minimize the loss function and hit a global minimum, so we can do actual like the best predictions with our model when it's done training. And then we specify the loss function here to be this sparse categorical cross entropy loss function. And then when we're doing training, we just want to see the accuracy of the neural network when we're training, so we will specify the metrics to show the accuracy of the neural network when we're training on it. So we see here, if we run the code here, first of all, we're just going to import the atom and the categorical cross entropy, and then we're going to do the actual like compilation of our model, and we've now compiled the model. And then we can see that the learning rate here of the optimizers is this like 0.0001, and we can see it here, which is this NumPy number here. And then we can actually like change our learning rate here with this model.optimizer.learning rate if you want to do it in that way, or like you want to specify the learning rate in this way instead of passing it as a parameter to the atom, or you want to like change it in some other way or in some other situation. So we can actually like change the optimizer's learning rate here. So we set it to 0.101, and then we can go down here and see that we have now changed the learning rate here to 0.01. So this is just another way to specify the learning rate of the optimizers, and then we can actually like do training on this model that we're now compiled with the atom optimizer and the loss function, which is sparse categorical cross entropy. So in the next video, we're going to do actual like training of this model here, and we can see like how it performs during training. So this is just a video that I showed you, like, so we know the basics about like what it does before the training, and what it does like while it's training with this optimizer here that's trying to optimize so the loss gets less and less when we're training our neural network, and also this loss function here, like how we want to minimize our loss functions. So that's it for this video, guys. Remember to hit the subscribe button and bell notification on the video, and also like the video if you like the content and you want more of it in the future. I'm currently doing a computer vision tutorial with OpenCV in C++ and an artificial intelligence tutorial where we have talked about reinforcement learning, and when we have been over like some different kind of projects where we have implemented Q-learning and a lot of nice different kind of stuff in that tutorial. So if you're interested in one of those tutorials, I'll link to one of them up here, or else I'll just see you in the next video, guys. Bye for now.